Lovely thinking question number 9. We're going each time till we've won 5 times, and the chance of winning is 0.7. And so the first one's just standard. We want to know the chance of winning for the 5th time on the 10th go. And so that means in the previous 9 goes, you've only won 4 times. So win 4 of them and lose the other 5. And then on the 10th go, win again. And so just tapping that into the calculator, I've got 0.05145, so 515. So that's standard. But the probability that x is less than or equal to 6, so the chance that we win for the 5th time on the 6th go, well, that'll be standard, or on the 5th go. Now, you can't win for the 5th time on the 4th go, so we don't need to go any further. And this one here, winning on the 5th go, well, that's just winning every single time, isn't it? So that's just 0.7 to the power of 5. And winning on the 6th go here, so this is the previous 5 goes, you only won 4 times. So win 4 times and lose the other 1, and then we win on the 5th go as well. So I'll just put that in there because I've run out of space there. So that there's giving me 0.4202. Now, even more thinking. This says we want to win for the 5th time sometime before the 15th game. So what we're going to do here is we'll change this into a binomial. And if I say we're now going to play a binomial, and we're going to play 15 games for our binomial, and the chance of winning is 0.7. And we want that we're going to win the 5th game sometime in these ones here. So we want to win at least 15 games. I'm going to use a Y here. Sorry, at least 5 games. So if we win more than 5 games in the first 15, that will tell us that our 5th win comes in the first 15 games. Seems like I'm going around in circles there, but it feels logical to me. Have a think about it, have a discussion about it as you go through that. So binomial, I want to win more than 5 games. Sorry, 5 or more games out of the first 15, 0.7. So that gives me 0.9993. Should we have a look? 9993, yeah. I had to think about doing that in a different way, actually. I don't know if it's still on the screen here. Yeah, I had to look. I was seeing if this worked. And so I've actually just done a summation, because in the old calculator we did this for binomial. I've added up all the negative binomials from 5 to 15, sort of doing what I was doing in the previous one, and working out with the summation, and it gave the same answer, which is nice. Part D, find the probability that x is greater than 12. So that would mean that in the first 12 games, we would want to win less than the 5, wouldn't it? Is that exactly right? Less than 5? Or less than or equal to 4, in fact, because that's what less than 5 is. Just think through the logic of that. If you win less than or equal to 4 in the 12 games, that means your 5th win will be after the 12th game. Yeah, that makes sense to me. So back to our distributions menu, distribution here, binomial, and this time I want less than or equal to 4 in 12 games, and that gives something quite tiny, 0.00949. 0.009489. So look, lots of thinking in that. Switching between the negative binomial and the binomial when I needed to, or have a play with a summation sign if you want to see if it is any